Hello everybody, welcome back to my channel, and today we'll be seeing how to find an element in a rotated sorted array. So what does a rotated sorted array mean? So for example, let's just see. So it looks something like this. Let me just take an example where 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here you can see I have made an array. So here you can see I have made an array where uh, from this part all the way till this is sorted, and then the after 6, suppose 7 comes, so then this part goes over here, so it is continued over here, so it is sort of rotated at the 7th position. Like at the 7th position is the pivot from where it just gets shifted to the first half. So this is what a rotated sorted array means, and we have to find an element in this rotated sorted array. Like we have to find the index of the element. So how do we do indexing? Is just 0 1 2 3 4 5 6 7 8 9. Now we'll be using the concept of binary search over here. So the two things which you have to remember in binary search is that in binary search it is applicable only for sorted arrays, and secondly it has a time complexity of big O of log n. So the only condition of this, like in the name itself it's written that it should be a sorted array. In the name itself is written that it should be a sorted array, and yeah. So let's just see what did I mean by binary search. Suppose if I had elements of 1 2 3 4 5, and my target which I wanted to find was 1, and also I also want to find target 5. Like I want to find the position of 1 and 5, and this was the sorted array. So what did I do? Firstly, I always used to find the mid element, and this was the start, and this was the end. So I compared the start, mid and end. Now the start, so suppose in case 1 I wanted to find target 1, like I wanted to find the position of the number 1, then let me just write the index also, 0 1 2 3 4. So what did I do? I compared the mid and the start. So what did I do? I just compared the mid and the target. So 3 is greater than 1, that is like the mid is greater than the target which is 1. This means I will be eliminating the right half. So how do I eliminate the right half, which is nothing but end is equal to end minus 1. And in case 2, suppose if I wanted to find an element which was on the right side, so case 2, and here the mid is smaller than the target, so mid is smaller than the target, and which is like my mid was 3 and the target was 5. So in this case what do? I eliminate the left half of the entire array, so which is nothing but start is equal to mid plus 1, sorry, and also here it will be end is equal to mid minus 1. So this was how a normal binary search worked, but here if we see, we cannot apply binary search directly over here. Binary search cannot be directly applied because it is not completely sorted, just like the first half and the second half are sorted, but in the entirety they aren't sorted completely. Directly applied. So what do? So let's start with the pseudocode. Like, let's see how does the pseudocode look like. So I'll be giving start is equal to 0, end is equal to n minus 1. Here n is the size of the array, while start is less than equal to the end. I check if array of, I firstly find the middle element. So how do I find middle? Middle is mid is equal to start plus end by 2. If, like, the three conditions will be checked. The first condition is if mid is equal to the entire target. If it is equal to the target, then I just return the position of mid. So if array of mid equal to the target, then I just return mid. The second condition is, like, in rotator sorted arrays, what we do is we first, like, in this, the main difference will be in the second and third condition. So in the second condition, like, first thing which we find is which part of the array is sorted, like is it the left part or the right part. So and every rotator sorted array will be having parts where the left and the right part will be sorted. So in this case, you can see from here all the way till here it's sorted, and then from here to here it's the second part which is sorted, which is the left and the right. So we first, then we identify which part is sorted. So if array of mid is greater than the start, and else array of mid is less than the end. So this basically means the right half is sorted, and inside this we'll be having conditions of, like, basically what did I mean by if array of mid is greater than the start. So in this case, what was the mid? The mid was nothing but 0 plus 9 by 2, which is 4.5, which is nothing but 4. So the fourth index is the mid. So mid start end. This was the first condition. This is the second condition. This is the third condition. So in the second condition, like, the left half is sorted. This just means array of mid is greater than the start. So array of mid is what? 1, and 1 is greater than the start? No, 1 is smaller than the start. This means the left half isn't sorted, which means the right half is sorted. And what was the right half? The right half is array of mid is less than the end. Array of mid, what? 1 is less than 6? Yes, absolutely. So yes, like, 1 is less than 6, that is array of mid is less than end. Yes, so right half is sorted. So it just identified which half of the array is sorted. Now after identifying which half is sorted, we, inside it, we look for the target and we compare. So we write if array of start is less than equal to the target, and the target is less than equal to the mid. This means the target exists within the left half, so we can just eliminate the right half. So how do we eliminate the right half? Which is nothing but start is equal to which is nothing but end is equal to mid minus 1. So we just do end is equal to mid minus 1, else start is equal to mid plus 1. And for the second half, if right half is sorted, so we compare, so we write inside this, there are more conditions which we have to check, which is if target is greater than array of mid, and the target is less than the array of end. This means the target element exists in the right half, so we can just eliminate the left half. So that is done by using start is equal to mid plus 1, else we can just write end is equal to mid minus 1. And for the sake of this is if else, this entire thing is 1. Similarly, this part is here, and this part is entirely here, and this is one entire thing, and all these three together are one entire block of conditions which are checked in this while. So finally it ends over here. Okay, this while ends over here. So this was it. This was the pseudocode of finding a element in the rotated sorted array. So now let's go to leetcode.com and try solving this question. So so this is the question in leetcode.com, like search in a rotated sorted array. So the two keywords which you have to like identify is if they have written in the question sorted. So here you can see sorted is written, and also another thing which they have told is do it in big O of log n, which means you are definitely going to use binary search. So you can't directly use a simple binary search as I explained on my iPad, but you have to do a little bit of changes. So the first condition of binary search will be the same. The changes will be in the second and third condition of binary search, where we'll be identifying which part of the array is sorted. So let's start. Yeah. So int start is equal to 0, int end is equal to nums dot size minus 1. Like for the sake of simplicity, just remember, like just understand that like vector is just basically an array, and the name of that array is this nums, and to find the size of the array is just like name of the array dot size. So I did that way. Now I will be like while start is less than equal to the end. So first condition, uh, so then I find the mid. Int mid is equal to start plus end minus start by 2. Now the reason why did I do int is equal to mid plus mid is equal to start plus end minus start by 2, why did I do this weird one, and why I didn't do in the normal one which we do is, which is nothing but start plus end. by 2. So you must be wondering, why did I do it this way and why am I not doing this simpler way? Basically both of them mean the same. Like if you do the mathematical calculations, it just means the same. But the reason why I'm doing like that is because uh, there is a limit of the integer data type. Like there is a size, the maximum size an integer data type can hold is 2 power 32 something. So what if, imagine, your start is like the biggest most value and even your end is also the biggest most value. So start biggest most value plus biggest most value, so it becomes a very big number, and then it gets divided by 2. So before even it gets even divided by 2, it becomes such a big number that this mid could never be able to store that value. So then you enter into the issue of integer overflow. So yeah, I'll just explain you this part later on the code. So for now, let's just keep it this way. I'll explain it to you. If array, sorry, if nums mid is equal to the target, return mid. Now we go into the second condition, which we find which part of the array is sorted. So if nums start is less than equal to nums mid, then I look for the target element inside it, and the way how I check is if nums of start is less than the target and the target is less than the mid, so it will be nums of mid. Then, like, basically what did I mean by this entire thing is that my target element lies on the left part of the array and that left part is sorted, which I checked by this condition. So this basically means I can just eliminate the right half. So how do I eliminate the right half? This is nothing but n is equal to uh, mid minus 1, else start is equal to mid plus 1. So this is the, and finally the last else is basically the right half of the array is sorted. If that is the case, then I just check if nums mid is less than the target and the target is less than the nums of end. Basically this means my target element lies on the right half of the array and the right half of the array is sorted. So I can just eliminate the left half, so that can be done by using start is equal to mid plus 1, and else I can just give it as end is equal to mid minus 1, and I just, so I guess that's pretty much it. So this is like the first if, this is the second one, and this is the third one, and this entire thing lies in this while loop. And if my, like, the value isn't returned, I mean if the element doesn't even exist, so I can just return as minus 1. Now let's just run this code and see how does it perform. So let's just run. So I'm getting wrong answer, so 0 doesn't exist, so output should be minus 1. I'm getting it as 4, so let's just see. I might have put it in the wrong while. It's okay, it's the correct one. Yeah, the thing which you have to do is that I feel you have to give equal to sign over here, and also you have to give equal to sign over here, because in this, both of these, like both of the conditions, like I'm not even checking the case, I'm not even including the middle part in the comparison. So these two things we do, and then we run. That's it. The code just got executed, and maybe in this question this part worked because maybe the test cases aren't so strong. But there are questions where you might run into an issue of integer overflow or something. Then you can use this part. But in this question, even the simpler one works. So let's just see. I think so. It should throw an error when I submit this code because all the three test cases are passed, and it throws an error. It wasn't seeing because here in this case the target was the last most element, which is 3. Like it should exist, like it should give out the position of 3 which is at the 2, but it threw me as -1 because I wasn't even comparing the target and the end one. So I just put a equal to sign over here and remove this equal to from here because I'm already checking this part over here, so I need not you know do that. So it just got submitted. So thank you so much for watching the video. Until so thank you so much for watching the video. Until next time, goodbye.